Hello, mathematicians. Today we're going to be learning about slope-intercept form, and more specifically, we're going to be using tables. So here I have a table where X represents the number of months and Y represents the gym membership. So at 0 months, you'll notice that it's $25. And what this means is that's an initial fee just to join the gym. So here, since it is 0, 25, our coordinate, 0, 25, that's our y-intercept because our initial value is our y-intercept. So after a month, after paying our initial fee of $25, you'll notice that for 1 month, the cost is $30. So after 1 month, it costs $30. So from 1 month to 2 months, that's an additional month. That'll be an additional $30. And then from 2 months to 3 months, that's an additional month, and that'll be an additional $30. And then from 3 months to 6 months, that's after 3 months. So that's an additional $90. And then from 6 to 8 months, that's an additional 2 months. And so that's an additional $60. Now, by looking at our table, at first, our table increases by 1 month at a time. And when it does increase by 1 month, it increases by $30 each time. And then from 3 to 6, it increases 3 months and it increases $90. So, just representing the first change, it was $30 for 1 month. So from here, from 0 to 1, 1 to 2, 2 to 3, that's all $30 per month. Then after a whole 3 months pass by, and we notice that our price increases by $90. So that's $90, but that's in 3 months. And then here, it increases by $60, but that's in 2 months. And even though it looks like our table's not following the same pattern, our rates are all equivalent. So that means it does still have the same rate, meaning it still has the same slope, so it is linear. So here, $30 per month, that's completely simplified. That's our unit rate. $90 in 3 months could actually simplify to $30 a month. And then $60 in 2 months, that simplifies to $30 a month. So I'm going to want to represent our rate in simplest form. So the gym membership, which is Y, is equal to, so we have 30x because it costs $30 a month, plus my initial fee of $25. So here my slope is 30 because the gym membership costs $30 per month, and my y-intercept is $25 because when you first join the gym, you have to pay an initial fee of $25 to become a member, which is very common in a lot of gyms. So let's take a look at our next table. So in this table, X represents the number of cookies and Y represents the cost. So 0 cookies is $0, so that's my y-intercept. It's just 0, 0. And that means that 0 cookies will cost you $0. So from here, from 0 to 2, that's an additional 2 cookies, and that costs $1. And from 2 to 3, that's an additional cookie, so that's just 1. And the increase here in cost is 50 cents. And then from 3 to 6, the increase is 3 cookies. And the increase in cost is $1.50. From 6 to 7, that increases by 1 cookie, so the increase in cost is 50 cents. And then finally, we have an increase of 3 cookies, and the cost increases by, again, $1.50. Okay, so our table looks like it's going up by different amounts. First, we go from 0 to 2 cookies, then 2 to 3, 3 to 6. So the increase here is not constant, but the increase in price is not constant either. So let's see what that means. So for $1, we get 2 cookies. So it costs $1 for 2 cookies. It costs 50 cents for 1 cookie. And then it costs $1.50 for 3 cookies. And that's it. We have no different values. So $1 per cookie, $1 for 2 cookies is the same thing as 50 cents per 1 cookie. And then that's the same thing as $1.50 for 3 cookies. So these are all equivalent rates. So our cost per cookie is 50 cents. And there are a few ways that you could write this in slope-intercept form. So the first one, you could definitely represent it as y equals 0.50x, and I don't have to add 0. And here what this says is that our cost is 50 cents per cookie, or you could write it as y equals 1 over 2, so a half x. So we know that 0.50 and a half are the same thing. But also notice here our rates. So we have $1 over 2 cookies, which is the same thing as 1 over 2. And here we have 0.50 over 1, which is the same thing as 0.50. Now, when we are graphing in slope-intercept form, it's a little bit easier to have the fraction, but you could certainly have a decimal here. And the reason why it's a little bit easier to have a fraction is because when we do, and we have 1 over 2, we know that this is our rise, and this is our run. So every time we go up, we go over 2, okay? So either way is acceptable. The second way is just a little bit easier to graph, in my opinion, but it's really up to you. Okay, so here we have another table where x is the number of minutes and y is the gallons of water. So we notice that before any time passes, we have 150 gallons of water. So that's our initial value, which is the same thing as our y-intercept. Zero, 150. And what this coordinate means is, again, our x is minutes. So before any time has passed, we have 150 gallons of water. Okay, so after 4 minutes, our water actually decreases. So this could represent something like a leak, or maybe you're pouring out water. So our water decreases by a gallon, so it goes down 1. After another 4 minutes, our water decreases by another gallon. After another 4 minutes, we have another decrease of a gallon. After 2 minutes, it decreases by half of a gallon. And then after another 2 minutes, it decreases by half a gallon. And the reason why I put +4, +4, +4, +2, +2 is because our minutes are increasing. And here the reason why I subtracted 1 and then here 0.50 is because our gallons of water are decreasing. And so we're losing a gallon of water every 4 minutes. And that happens here, here, and here. So the same thing happens. And then here we're losing half a gallon in 2 minutes. Okay? And so here, when we're losing 1 gallon in 4 minutes, that's the same thing as losing half a gallon in 2 minutes. Okay? So just by looking at these two rates, the first one we wrote here is a lot easier to look at. So that would be -1/4 rather than writing -0.5 over 2. So this one is a lot nicer to look at, and the second one isn't even a proper fraction. So that's kind of what I meant too, looking at this previous example, but the fact that it's over 1, we could just write it as 0.50. This one is over 2, so I'd have to write it as -0.50 over 2, or I'm just going to write -1/4. So here, our gallons of water is decreasing 1 gallon every 4 minutes, and then X represents the number of minutes, plus 150, which is the number of gallons we started with. So our slope here, -1/4, represents that we're losing a gallon every 4 minutes, and the 150 represents the number of gallons we start off with. So here, by substituting X for any number of minutes, we'll know how many gallons of water we have after X minutes. Or if we wanted to know how much time has passed, we would have to just substitute the gallons of water that we have. And here's our final example. In this case, X represents the number of hours and Y represents the percent of battery. So here, our Y-intercept is 0, 100. And what that means is before any time has passed, our percent of battery is at 100%. And as time goes on, our percent decreases. So after an hour, our battery percentage goes down 8%. After another hour, it goes down another 8%. After 3 hours, the percentage decreases by 24. After 2 hours, it decreases again, and this time it decreases by 16. And then after 1 hour, it decreases by 8. So we're losing 8% of battery every hour. And we're losing 24% of battery after 3 hours. And we're losing 16% after 2 hours. And as we could see, even though it doesn't look like our table, our percentage is decreasing by a constant rate, it is, because we lose 8% every hour. We lose 24% in 3 hours, which is the same thing as 8% per hour. And we lose 16% in 2 hours, which is the same thing as 8% in an hour. So, because these are all equivalent, and this is my unit rate, our percentage decreases by 8 every hour. I don't need to write -8/1 because -8 is the same thing. So -8x plus 100. So our slope represents the percentage of battery we're losing per hour, and 100 represents the percentage of battery that we have before any time has passed. And that's it.